This is Unit 6, Section 1, Notes, the nth root and simplifying radicals. No, I did not mistype that word. It's supposed to be NTH. That's just what it's called. N being any number. So anyways, before we can give all possible roots to any radicals, we have to figure out what are the roots and what are radicals, right? A radical is simply just a square root, or a cube root, or a fourth root, or any kind of root. That is what a radical is. Okay? So when we talk about nth roots, that's just some number multiplied by itself however many times to equal the given number. So if I say the square root is a number times itself twice, a cube root is a number times itself 3 times, because cube is 3, square is 2. Fourth root is a number times itself 4 times, and if we can keep going, fifth, sixth, seventh root, seventh root is a number times itself 7 times. Whatever number you want to put there. Now, for this class, or these notes, I'm only going to do 2, 3, and 4. And I'm not going to go too high on these because they can get very difficult once you get into 4 digits and higher. So we're just going to focus on these. So for squares, these are numbers whose square roots are whole numbers. Cubes are numbers whose cube root is an integer, positive or negative. So pretty much a positive or negative whole number, right? A perfect fourth is a number whose fourth root are whole numbers. And we're only going to go, if you notice, 1 through 25 on squares, 1 through 10 on cubes, 1 through 5 on fourths. Because again, past that, it gets really hard to remember. And I'm not expecting you to remember all of these, but these will be the main ones that we'll use. These will be the ones I'll use a lot. I'll try to use them as much as I can. So let's go ahead and just go through these real quick. That way you at least have them. And if you know them, it'd be fun if you could try, if you want to pause, try to write as many as you can that you know. That'd be kind of cool. If you don't know them, that's totally fine. So a perfect square that equals 1 would be simply square root of 1. Square root of 1 equals 1, right? Okay. So what square root equals 2? That'd be 4. So square root of 4 equals 2. 3 is square root of 9. 4, square root of 16. 5 is square root of 25. So the way you would use this, this little cheat sheet part right here is if I'm looking, if I have like the square root of, so I have a square root of in this column, right? Then my answer is going to be some number over here. So if I see the square root of 9, my answer is 3. If I see the square root of 25, my answer is 5. So that's how you should be using this. And you probably will have to use this for a lot of questions. That's fine. But over time, you may find yourself not needing this as much, which is better. Again, not necessary to remember everything. That's fine. So 6 is square root of 36. See, some of these you probably know. 7 is square root of 49. 8 is square root of 64. 9, square root of 81. 10 is an easy one, right? 100. Most people will remember that one. Alright, 11 is square root of 121. 12, square root of 144. And typically that's where most people stop as far as what they learned, in elementary. If you did the times tables, you only go up to 12 times 12. No one goes past that because, again, they're not as common, which is why we don't. But for squares, it's, I guess the most common ones are up to 25, so that's why we go up to 25. So 13, and maybe some of y'all know these. 13 is 169. And 14 is easy if you know 13. It's just 196. The back two are flipped. Alright, 15 is square root of 225. 16 is square root of 256. 17 is 289. 18 is 324. I don't know why, but I always remember that one. 9 is 3 square root of 361. 20 is easy. 400. 21 and 22 aren't too bad, but for me it's 23, 24, I forget all the time. So 21 is 441. 22 is 484. 23, square root of 529. 24 is square root of 576. And 25 is 625. So those are your squares, your perfect squares, from 1 to 25. Again, for all of my stuff, I don't go past 25 on the squares. So if you know those, or if you can memorize them, if you remember them, great. If not, that's okay. You have them written down, so you can always look at these up if you need to. All right, cubes. So these are cube roots, whose root is an integer, so you can have positive or negative. Because it's odd, that's fine. For square roots, remember you have the plus minus. Same with the fourth. So any even root, or even index, I'll go over that in a minute. So even index, well, you'll have positive, negative, but odd, like a cube, is 3. That's an odd number. You can have a positive or a negative, never both. Alright, so what cube root equals 1? Well, that one should be easy. It's just the cube root of 1. Okay, 2. What cube root for 2? So if you think about it, 2 times 2 times 2, right? Because I'm multiplying 2 by itself 3 times. So that's how you can figure these out if you don't remember. So 2 times 2 is 4, times 2 is 8. So that's the way to know these if you don't remember, which is okay if you don't. You can always work backwards from the answer. So like for 3, I would do 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27. Okay, 4 times 4 times 4. 4 times 4 is 16, times 4 is 64. 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. Okay? And then notice we only have 10 on these, because again it gets kind of crazy after that. So 6 times 6 times 6. 6 times 6 is 36. Times 6 is 216. 7 times 7 is 49. Times 7 is 343. 8 times 8 is 64. Times 8 is 512. 9 times 9, this one's kind of easy. 9 times 9 is 81. Times 9 is 729. Because 9 times 1 is 9. 9 times 8 is 72. So that one's not too bad. And then 10 times 10 times 10. This one's probably the easiest, besides the first few. 1,000. Alright, so there's your perfect cubes. And then lastly is perfect fourths. And notice I only do 5 of these because again it gets too much. So these are a number times itself 4 times will get you the fourth root. So this one, of course, the ones are always going to be 1. Because 1 times itself, no matter how many times, is always 1. 2. So I would do 2 times 2 is 4, times 2 is 8, times 2 is 16. And if you ever forget, you can always go back. So if I look at the 2, my 8 is 3 times, so 8 times 2 would give me the fourth, which is 16. So 3 times is 27, right? So now I would do times 3. So 27 times 3 is 81. 4, so 4 times. So 4 3 times is 64. 64 times 4 is 256. And then 5. 3 times 5, or 5 times itself 3 times is 125. So 25 times, or 125, sorry. 125 times 5 is 625. So there's your fourths. So you have perfect squares, perfect cubes, perfect fourths. Those are the only ones I'm going to use. I will never use any other ones besides these. So let's talk about a few other things though that you need to know. So first thing is, let me just draw we have, here's a basic form of any root. Okay? So, everyone, you should recognize the square root symbol, like the line that goes up and over. You have a little n is any number, and the a is the number, of course, underneath. So if you look at the one right above this, the third root of 125, my n is 3, my a is 125. You can put any number in there, okay? But here's what this means. So actually, let me change the n. You don't have to erase it. I'm just changing the color. So n just means the index. So if you just remember, n is index. Your index is the type of root. So if the number there is 6, it is the 6th root. If the number there is 3, it's the 3rd root or cube root. If the number there is 10, it's the 10th root. So whatever little number is there, that's the index, that's the root that you're looking for. Now, there is one exception. If you don't have an index, so no index equals 2. So if you notice on all the square roots that we wrote earlier, or that you've ever seen in your life, on any square root, no one ever writes the 2. That's the only one that's blank. And you can't do a single root. That's not possible. Because you can't do a number times itself once. That would be 2 of them. So that's why. The square root, there is no index, but it's implied that it's 2. Any other index, it'll have to be there. So 3 on up, any root there, you'll have to put a number. So if there's no index, it's 2. So for example, like square root of x is square root, that would be a 2, even though there's nothing there. But if I had a 3rd root of x, I could have a 6th root of x, I could have a 10th root of x. You could put any number there. Whatever little number is there is your index, okay? Now, what's the other number called? That's called a radicand. I'll write it out for you. So again, I'm just going to change the color. So A equals your radicand. So in case it's hard to understand, radicand. Okay, that's just the number underneath the radical. So if I'm looking at this and I'm dissecting what it looks like, I'm taking the index root of the radicand. That's really what it is. Okay, so the square root of A, or like down here, the square root of x. My index is 2, my radicand is x. That's it. The radical symbol is simply the line that goes up and over. That's all that radical is. But the radical in itself is the whole thing. Okay? So we have index, we have radicand. Those are my parts of my radical. Okay? Now, there's something else that even index roots have. It's called a principal root. I promise we're done after this, and then we can go to the problems. So a principal root just means that this is only for even index. So even index radicals, okay? For even index only. This is just where if you already have the root there, the radical is already in the problem. So I'm trying to figure out how to best explain this in as few words as possible. So this is for even index only. So if root is already, oh wow, I spelled that wrong. Already. Oh, I spelled that wrong too. So if root is already in the problem, the principal root is just the positive root is found. So principal root is only for even index, so only square root, only 4th root. I mean, it is true for 6, 8, 10, so on, but for us, for this unit, it's only 2 and 4. So the cube roots, this does not apply. So for even index roots, for square roots and 4th roots, if I already have a root in the problem, then when I solve and take the square root or take the 4th root, I don't put the plus minus, I only do the positive. Okay? So just real quick, so if I have square root of 100, and it's already, like, that is my problem. I didn't put the square root there. If the square root is already there when I start the problem, I'm only going to write 10. I'm not going to write plus minus 10, right? I don't want that. I only put the positive. That's all the principal root means. So for all of this whole chapter, if you ever see a square root or a fourth root in any problem, you do not put the negative, okay? Just the positive answer only. So that's it for the notes part that you need to understand. So because I'm going to use words like index a lot, I just wanted to make sure you knew what that was. And then principal roots, that's why whenever we do, let's look at number 1. Principal roots, give all possible roots to the radical. Okay. So if I do square root of 361, because my index is 2, even though I didn't write it, and it's already in the problem, I'm only going to write the positive answer. So if you look at your notes right below this, square root of 361 is just 19. That's it. Not positive, negative 19, not plus, minus 19, none of that. Just 19. Okay. So let's move on. Notice this is an odd index because my index is 3, and I have a negative. That's okay. If I have an odd number, if my index is 3, I can have a negative answer. That's totally fine. So all I do is look at cube root of 512. So if I go to my notes and look at 512, I notice my answer, my root, is 8. And because my number is negative, my answer is also negative. Again, that's only true for odd index. Only for cube roots only, right? Okay. Look at this one. Index is 4. So I go to my fourth roots. Fourth root of 256 is 4. That's it. No plus, minus, no negative, none of that. Just 4. All right. Hopefully I did not confuse anybody in this first part. I know this is a lot of information. It'll kind of make sense though as we keep going. Okay, so section B, I want to simplify radicals, and now I have variables. I don't have numbers. So this is a little different. Okay, so on here, if you notice, I have x to the 4th, y to the 5th, and it's a square root. Okay, so I'm going to rewrite these to make these a little easier. So for x, I'm going to write x, and the way you write this is you write the exponent on top and then the index on bottom. So if you want that on notes, like down here, so if I have index and variable, I'm simply going to rewrite it as, exponent. Well, here, let me change that, x. So I have index, I have exponent. I'm just going to rewrite it as x to the exponent over index. Okay? That's the only notes you need for this part. Mostly. So I need to rewrite that first. So I'm going to go ahead and do that. So notice, because my index isn't there, it's a 2. So I have my exponent is 4, my index is 2. So here's my n, here's my e, here's my other e, right, for y. So I'm going to go ahead and write y, exponent over index. Now the reason I write these separate like this is because now we have to divide or simplify, right? What is 4 divided by 2? That simply reduces to x squared. We have nothing else. Okay, so that one was pretty easy. I did it on purpose. Now, 5 divided by 2. I can't do 5 divided by 2, so here's how I always do these. I'm going to split this up, right? I can't do 2 into 5, but I can do 4 divided by 2, and then I can have 1 divided by 2. So I'm splitting this up into two numbers on top that add up to 5. 4 plus 1 does equal 5, and I can do 4 divided by 2, which is great. So now I keep going. So now I'm going to focus on this first one. So just this one. What is 4 divided by 2? Well, that would be 2. So we have y squared. But look at this one. I can't do 1 divided by 2. That's 1/2, right? So because I can't reduce that, I'm going to convert that back into a radical. So if I'm going back down here, if I have x to the exponent over index, I'm going to convert it. I do index and then exponent. So I just go backwards. So again, my top number stays on top. My bottom number becomes the index. Okay? So that's all we're going to do here. I can't do 1 divided by 2, so when I rewrite this, I'm going to write my index. So there's my index, square root of y. And since my exponent is 1, I don't have to write that. If it was any other number, I would, but I don't need to. Also, because my index is 2, I don't need to write the 2. I can just do square root. Either way is fine. I don't mind. If you want to put a 2 there every time, you can, just so you don't forget. Okay, so I'm going to put my answer together. So my answer is going to be the x and both y's. So I always write my stuff in alphabetical order. It really doesn't make a difference. You don't have to. It just, if you are consistent in how you write the answers every single time, this will definitely get easier the more you practice. So I write my answers in alphabetical order, and I do outside first, and then inside second. So that would be my final answer. So, just to recap, we split the letters out of the variables. So we have x here, we have y here. We divide if we can, we split up and then divide if we can't, and then we put our answers together, and that's it. Okay? And again, this seems like a lot, but it definitely gets faster the more you do this. So let's look at number 5. So again, I have my index is 3, and I have a to the 7th, b to the 12th. I'm going to rewrite these. So I have a to the 7 over 3, so exponent over index. And I have b to the 12 over 3. Okay? Now, I'm going to go ahead and do b real quick, just because I know 12 divided by 3 is 4, and I'm done with b. So a, I can't do 7 divided by 3, but I can change 7 into 6 and 1, right? Because 6 plus 1 equals 7. Now I can do 6 divided by 3. So 6 divided by 3 gives me 2. And I can't do 1 divided by 3, so I'm going to have index of 3 and then a with my exponent. But again, you don't need the 1 if it's there. That's fine. So my answer is going to be my a's and my b's. So if I write this together, I'm going to have a squared b to the 4th cube root of a. Okay. See, after you do it a few times, it actually doesn't take that long. It's just explaining it the first time. I have to go a little slow. But overall, it's not that bad. But here, let's try one with with 3 letters. I don't know why I said 4. It's the 4th root. Alright, so my index is 4 on this one. So I'm going to have j. Remember, if I don't have an exponent, it's a 1, right? So 1 over 4. I have k to the 7 over 4. And then I have m to the 10 over 4. Okay, none of these I can divide. So I'm just going to start with the first one. I can't divide 1 by 4, and I can't even split 1 up. So that one is just going to stay 4th root of j to the 1st power. And that's it for the j. K, I can split that one up, that's 7. I can do 4 over 4 and 3 over 4. Okay, my 4 over 4, this first one, 4 over 4 divides into 1. So I can either put my exponent, I don't need to. And then this one right here, the 3 over 4, I would just have my 4th root of k to the 3rd power. Remember, your top number stays on top. Your bottom number becomes the index. Okay? And then my m, 10 over 4 I can split up. I have 8 over 4 and 2 over 4. Now you're probably thinking, oh, I can reduce that 2 over 4. You don't want to. You could, but your answer would be more complicated, and I don't want to do that. So we're just going to keep it. Alright, so the first one, 8 over 4 reduces to 2, and 2 over 4 does not reduce, or not, I should say, it does not divide. I can't divide 2 by 4. I can reduce it, but I'm not going to, because I want to keep it all the same index. That just makes my answer easier. Because if you could reduce it, but then you would have 2 different radicals in the same answer, and I don't want to confuse anybody, so we'll just leave it. So I have J, K, M. So I have outside letters first. I have K, M squared, and then notice because I left the index the same, they're all a 4th root. That's why I do that. It makes it easier. So I have 4th root of, I have J, K cubed, and M squared. And that's my final answer. So definitely takes practice on these. You're definitely going to have to do these a lot. That's why there are a lot on the homework. Alright, moving on, last part. I know this is a long video, but you know, a lot of information at the very first section. So now I want to simplify non-perfect radicals. So there's no variables in this part. Alright, so for these, simplifying non-perfect, notice we don't have variables anymore because they're just different. We're going to do numbers that are not on our perfect cube, perfect square, perfect fourth list. Okay? So let's start with the first one. So notice I don't have a square root of 80. So here's what I'm going to do. I have to notice my index. Okay, so my index is 2 because I don't have one. So because my index is 2, I'm sorry, I'm looking for groups of 2 when I do this. So when we do these, we're going to break this number down because there's no square root of 80, but I can split this up, right? So I know 2 numbers that multiply to 80. I can do 2 and 40. Okay? You don't have to do 2 and 40. You can do any number. I try to just stick with 2s if you can. But you can do whatever numbers you want to. But I always like 2s, 3s, and 5s, you know, those kind of numbers, because I want prime numbers that can't be split up. So if you have one number that is prime and one number that is not, to me that's how I always do it. It's called prime factorization. You don't have to do it that way. You can do 10 and 4, you know, 20 and 4, whatever, or, sorry, 10 and 8, 20 and 4, whatever you want to do. So I did 2 and 40, and then 40 can be split up into 2 and 20. 20 can be split into 2 times 10. 10 is 2 times 5, and then I can't do anything else. Okay, and if you want, like, you can X out the numbers that you split up, that we don't look at those. Okay, so I don't want any of those numbers. So you only want to look at the numbers that are left, the prime numbers. So I have 4 2s and a 5. So here's what I do. Because my index is 2, I want groups of 2. So your groups have to equal the index. If you want to write that down somewhere, you can. Groups equal the index. So my index is 2. I want groups of 2. So there's 2 2s and there's 2 2s. And then I have this 5 that's just by itself. So I'm just going to box that in. So I do circles and boxes. You can do whatever you want to. But if you make them different, it's easier so you know what's outside and what's inside. Okay. Now, for every group that I have, so I have a group of 2, I'm going to have 2. Okay, so for every group, I just write the number 1 time. And then I have a second group of 2, so I write 2. And then I have my box, my square, my 5 is by itself. So that just stays, whatever is boxed and not in a group, goes back under the radical. Okay, so because 5 doesn't have a pair or a partner, it's by itself, so it's staying in the radical. And then my numbers that are outside, if I have more than one group, like I do here, and I have more than one number outside, you always multiply. Okay, so then I do 2 times 2, I get 4, and my square root of 5 doesn't change. Now, again, if you had split the 80 up into 2 different numbers and gone from there, you would still end up with the same answer. I always just do it, like I said, with prime numbers like 2, 3, 5, 7, stuff like that. That's just how I've always done it. But if you want, we can do it differently on here. It doesn't matter to me. So let's do this one. So notice on here my index is now, I don't know why that's different color. So my index is now 3, which means I want groups of 3, not 2. Okay, so I'm going to split this up. So 54. I know that 9 times 6 is 54. And see, like, neither one of these are prime, that's fine. You don't have to do prime numbers every time. You could do 2 and 27. That works too. Now, the only thing with here is both of these can split up. So 9 is 3 times 3. 6 is 3 times 2. Okay? And then I can't do anything else, so these, I don't want these numbers. I don't want to look at those numbers, okay? So because my index is 3, I want groups of 3. So notice I have a group of 3 3s. And then I have this lonely 2 by itself. Poor fella. Or, I don't know. So, for every group, so I have a group of 3, so I write the number 1 time. I have a number by itself, so that stays in the radical. That would be my final answer because I don't have any other numbers. If you had multiple numbers either inside or outside, you always multiply. If I only have one outside, one inside, that's it. There's nothing else to do. Okay? So I have one group of 3 and I have just a single 2 still under the cube root. Alright, last one. Index. I know you're probably thinking this video is forever. That's okay. If you were in class, it'd probably take around the same amount of time. So, my index is 4. I want groups of 4. So 48. I can do 4 times 12. Okay? You could do 2 times 24. You can do 6 times 8. Whatever numbers you want to choose are fine. Okay, so 4, I have 2 times 2. And I changed. Remember, you don't have to cross them out. It just helps some people. That way you don't accidentally choose those numbers to put in or outside the radical. So if you split it up, cross it out, then you know that that number's out. Okay, so I have two 2's, and then here, 12, I have 4 times 3, so I split up 12, and then 4 is 2 times 2. Okay, so I have 2, 2, 2, 2, 3. So my index is 4. I want groups of 4. So look right here, I have a group of 4 2's, and then I have just a single 3. So because I have one group of 2, I'm going to have 1 2. And then because I have a 3 by itself, the 3 stays under the radical. And that becomes my whole answer. So I know you've probably learned prime factorization at some point, or hopefully you should have learned it at some point. So this should look familiar. It's just how we're using it now as far as using it with radicals. So that's it for the lesson. Hopefully you practice. This is kind of new stuff, so I would highly recommend doing the homework and checking your answers.